Hey, 3D modeling class. It's week 11. Today, I just want to revisit the glass situation a little bit. That was kind of a listener request, and I'm a little bit better prepared to explain it to you. Then we're going to look at geometry nodes. This one's kind of cool. You know, I realize that I say that. I've been saying that a lot for a lot of these lectures, but it's another cool thing. Okay, so quickly, let me just explain kind of a little bit better how I had set up the glass material with regards to the shadows, the light casting through it, things like that. So I'm very quickly going to set up a new scene here. Shift A, add a plane, scale that up. Shift A, add a monkey, GZ, move that up. Let's go to render preview real quick. I also want another light in the scene here because, make that a little bigger and also just move that over here. Okay. Great. And that is going to be, 500 or something like that. Okay. Suzanne, control chew, shade smooth, and maybe even shift control A, apply visual geometry to mesh. Okay. Material on Suzanne, make a gold metallic roughness up a little bit, metallic down a little bit. I don't know, make it a little lighter color, and metallic back up. Sure. World down to black. Okay. Do I like that material? Roughness up a little bit, sure. Okay. Now, to put this in a snow globe, to use an example from recent memory, Shift A, let's get an icosphere. I'm going to use an icosphere just because it's a little bit, the polygons are a little more even. Whereas if you use the other one, which is a UV sphere, they're really tight at the top. So I'm just trying to get things to be, the polygons to be of the same size and shape. So I'm going to put a control 2 on this as well to subdivide, right click, shade smooth, and then maybe even control A, apply visual geometry to match like this too. Okay, now let's add our glass material onto the icosphere. I'm just going to do the default glass guy here and roughness down. Okay, I have clearly done something incorrect. Do I need to change? Why am I not seeing Suzanne? It is, of course, because we are in Eevee and not cycles. There we go. Cycles me. Okay, great. GPU compute. Okay. All right, so here's what's happening. Suzanne is in there. Suzanne is getting blown up. Let's even make Suzanne a little smaller. And I should make Suzanne just a normal color too. Let's just do not metallic. Okay, so here and look at the IOR. For some reason that is 8. So I'm going to switch this to Beckman. I'm going to switch this to 1.5. There we go. Okay. Suzanne, you can go back to being shiny if you want. Metallic up. There we go. Cool. That's looking golden. All right. So here we go. We did it. Let me just move my camera a little bit higher and a little bit wider so we can see it. Make the ground bigger. Okay. So Suzanne is inside the glass. And, we're seeing it. So there is some distortion that happens with glass. So Suzanne is bigger than she appears because the glass kind of bends like that. And so that is that's what the IOR value does. It's the index of refraction, I believe is what IOR stands for. So if you make this exactly 1, it's going to be basically invisible glass. There's no refraction. It's the light travels through it at it does not change its path at all. It's 100% just letting the light go right through it. That's what the value of 1 is. So if you go like below 1, you can't. So if as you go up, as you make this number larger, it refracts more. It's the index of refraction. Okay, here's what was happening before, I think, when we were looking at some other examples. So I'm going to do like 1.1 like this. How I had told you, so what we're not getting is like a very nice like shadow. You might expect a little bit more light to come through the scene here like this. So maybe if I, actually I'm going to hide this. I'm going to hide this area light. So if we just have this one light here, you can see that like there's barely any light traveling through to the other side. So how did we fix that? We went to the shading workspace. Let me get back into my render preview here. Let me click on the glass. So what I recommended was using a mix shader. So I'm going to go Shift A. This is mix shader, like this. And then the other one to use was a transparent, not translucent, transparent BSDF like this. Okay. Okay, so this is when we were getting the double situation. And that's because if you have it set up like this with a mix shader, the factor is at 0.5 or 50%. So it's saying, okay, this is half glass, half transparent. So we are indeed just seeing the two different results of the two different materials on here. So like we're seeing half this one and then half this one. And it's overlaying them because it's a factor of 50% each. So like if you slide it this way, it's going to be more transparent. If you slide it this way, it's going to be more glass. So that's why we have to use the input of light path here. So put the light path input into your scene. Okay, so what this is going to do for us is it's going to decide, based on which input we choose, which material to choose. So the problem here, and I've sort of begun to understand how this is working, the light path situation. The problem is our shadow. So like we want the glass to be casting the transparent shadow. So we need to know if the ray that's coming or that's hitting our material is going to generate a shadow. So that's why we want light path is shadow ray. So when we connect this to the factor, if the path of the light is going to be a shadow ray, choose transparent. So like wherever the light is traveling, it's going to generate a shadow, choose transparent. Wherever the light is traveling and it's not going to be a shadow, so for example, if it's going to bounce back and hit the camera, choose glass. Or if it's going to be reflecting off of another thing, choose the glass. So that's what this in the factor here, this is saying if the light's a shadow, choose this one. If it's not, sorry, other way around. If the light's going to be a shadow, choose transparent. If it's not, choose this. So now we're getting the shadow of Suzanne through there, but we're not, it's transparent where the glass is. So this is where we have to get a little bit creative. So we can maybe, instead of this being totally white, we can you can bring this down a little bit and give it just a little bit of shadow like this. And now we are, again, only seeing the one Suzanne in the thing. And it's still doing the refraction, So you can see that it's a little bit distorted. And if I click on the glass again, if I change the IOR, it's still going to, do that thing because the light path is not a shadow when it's, bouncing around inside the glass or it's doing the refraction or the reflection. It's only choosing transparent if it's going to be a shadow. Is that making sense? I'm waiting for a response. No, kidding. All right, I think 10 minutes. I think that was, I think that's enough. But if you still have questions, ask me or look it up or we can figure it out together. All right, it's time to talk about geometry nodes. No, that's too high. Get somewhere in the middle. There we go. File, new, general, Okay, don't save. Here we go. Deleting my camera and my light. What is geometry nodes? So geometry nodes are sort of, it's like the word I use is procedural. It's sort of like doing modeling and kind of changing message and shapes and things, kind of using the node system. So it's probably easier if I just kind of show you an example. So here we go. If you don't have the geometry nodes workspace along the top, just hit the plus button and go to general, and it's here in geometry nodes. So geometry nodes workspace. So there's 3 windows in here. You know, your viewport, node, workspace. This one up here is like a spreadsheet. So this can come in handy if you're really getting deep into like understanding how geometry nodes work, because geometry nodes like calculate all the different position of all the vertices and things like that, and edges and things like that. So like, if you're into the math aspect of this, you know, you can keep the spreadsheet open. I'm going to go ahead and just close it like this. So this is really the only new thing that the geometry nodes workspace offers us is just like the node area down here. Okay, I've got the cube selected. Let's hit new and create a new geometry node. So just like any other node that we've done, either with compositing or texturing, we work left to right. So we've got an input, which is the geometry that we start with, and then the output, how it changes and then sends it back to the thing. So you put things in the middle and things happen. So let's just start with a very basic one. I'm going to go Shift A. And, you know, one of the very basic ones is, if I search for it, is transform. Transform geometry. Geometry, operations, transform geometry. So I'll drop it on here. So, you know, the geometry comes in. We're going to change it, and then we'll spit it back out. So I'm just going to do, you know, X, move that far, scale in the Z, you know, up like this, and scale in the Y, you know, down like this. So it makes it really skinny and tall. There we go. Geometry node done. So, just like your materials and all that other stuff, even actions in the action editor, for those of you that are doing animation, like we can name this and save it. This could be like slide and stretch. That's the name of our geometry node. So like you can apply this node to another thing. So like back on my scene here, I'm gonna go Shift A and, you know, Shift A, mesh, monkey. And, you know, I'll move over here, and maybe I'll even like rotate a little bit like this. But I'm gonna like hit this drop down and select slide and stretch, or actually you have to do new like this, I believe, and then do slide and stretch. And now Suzanne is slid and stretched. There we go. And so it's like, you know, modular. You can apply it to other things, but it's also non-destructive. So like, you know, Suzanne isn't like, so you can see like Suzanne's origin point is still here. And, you know, this cube's origin point is still where it was. It just, you know, was transformed using geometry nodes. So like you can just disconnect this, it goes back to where it was. You can just disconnect this, it goes back to where it was. And we still have our, you know, geometry nodes. Oops, we still have our slide and stretch here. Slide and stretch. Cool. Now, understanding the capabilities of geometry nodes it's sort of like mind bending a little bit, and it's one of those things that like if you see something that is you know, like a random pattern of things, or something that you know, is kind of done automatically. If you see someone else's project and they're like generating tables and chairs and things like that, the most likely answer is that it's done using geometry nodes. But it's like where to even begin doing stuff like that. So it's sort of like mad science. You just sort of have to like experiment with things and try different nodes and be like, oh well, if I use this node and if I use this node, like then I can do this thing. So it's like there's no like one tutorial to be like, now I understand geometry nodes. It's sort of like it's kind of experimentation and messing around with it and finding out what happens. So I'm going to start with like a couple of very Well, and here's the thing. Very basic. I was about to say very basic geometry nodes. But it's like the combination of multiple nodes working things together that can create some really cool stuff. So I'm going to say we're going to do a simple example of how you could do geometry nodes beyond, transform geometry. So the next thing I want to do is I want to create use a noise texture to create a landscape, to create sort of like some topography, not topology, but topography. So create some like mountains and hills and stuff like that procedurally. So we start with a plane, just like a big old plane like this. We don't need to edit it. We don't need to do anything like that. Let's just do a new geometry node, and we'll call this like generate landscape. If I can select this, generate landscape. And, so let's Shift A. Let's look at. We can even just look through here a little bit. So we've got attributes. We've got attribute statistic inputs. Some of those are less exciting. Operations. You can bake. You can duplicate things. You can transform. That's the one we did. Transform geometry. Curves. Curve of point. Primitives. Like it'll create things for it. Instances. Rotate. Mesh. Simple. Operations. Like look at this. You can extrude mesh as part of these things. So like any tool, any like thing that you can do while you're modeling, you can kind of like program a geometry node to do it. But it's sort of like how do you tell it to do that? How do you give it the right parameters to extrude? Mesh to volume. The one we're going to do right now is actually subdivide mesh. So in order to like create a landscape, we can't just have 4 corners. We need to have a subdivided mesh. And yes, you could just like right click and subdivide a bunch of times or put a subdivision service modifier on it, but let's use geometry nodes this time. So this is in mesh operations, subdivide mesh like this. And you can see that there is, levels. Let's just do it 1, 2, 3, 4, 5 even. 5 levels of subdivision. So if I go into edit mode, just like it's still going to look as if it's one thing. But as part of our operation here, we're going to subdivide this. Okay, now let's bring in our noise texture. So let's see. Shift A, just search noise like this. Texture, noise texture. Here we go. So we've got our noise texture. Okay, so now, we can't really see what this is doing. And how do we use the noise to change the values of the bumpiness of this? And we do that with the set position node. So Shift A, you can just search for it because I don't even know exactly where it is. Set position. It's geometry right. Okay, geometry set position. So put that one over here. So first we're subdividing, and then we're going to set the position of the geometry based on the noise texture. So let's see, we've got selection, position, offset. Let's just see what these do. I'm going to take the factor maybe and do selection. No, not doing anything. Position, did something, made it invisible. And offset like this. Aha, offset. So you can hopefully kind of see what is happening here. So you can see we kind of have the like shell, the empty shell where this used to be. And we can see that now it is, up and to the right and forward from where it was. So it's moved it in 3 positions. It's moved it in the positive X, the positive Y, and the positive Z, all of these things. So actually just for fun, like you can see that as I lower the subdivision, the subdivide, you can see all that additional detail that's coming from the noise. We can also see here that if I change the scale of the noise, it's going to change kind of the bumpiness of it. If I do scale all the way down, we can do things like this. Ooh, yeah, kind of cool. Okay, so how do we improve on this? How do we actually get it to do exactly what we want? So it's taking so first observe here that it's taking the factor of this, which is like a black and white image basically, and it's converting it into a purple socket here, which is a vector. So let's do some vector math real quick, and the one we want is going to be multiply. Multiply. Is this, no? Hold on, which one? I think it's just going to be vector math. Vector math. There we go. Utilities vector math. Okay, so stick this one in the middle here, and so if we only want this to go in the z direction, we don't want it to be moving in the x and the y. We need to be multiplying. Let's see. Is this? Oh yeah. We need to be multiplying the x and the y by 0. So if I go change this math, so this is vector math here. Change it from add to multiply. You can see now it's multiplying the x, the y, and the z by 0. So it's flat again. So just remember, like 1, 2, 3 is x, y, z. So if I change the z value, you can see that now the z is moving, in a dynamic way. If we can do x like this, you can do y like this, but we want to keep the x at 0, the y at 0, and we're just going to move the z. Okay, cool. And then, if we wanted to like move down, I suppose we can add another vector math like this. We can go Shift A and vector math. That's the first one up there. Don't even need to type it in. And maybe we do like subtract, maybe, and subtract the z. Subtract a little bit of the z like this, so it sort of stays in the middle like that. Cool. And look, we've sort of done it. We have something that can procedurally generate landscapes, and like, so rather than needing to like sculpt or do whatever, we can just say, oh yeah, I want it to be like a little bit like a little more mountainous like this, or I want it to be a little less mountainous like this. You just change the scale. Or I want it to be, you can change the detail. I want more detail in the noise texture, or I want less detail in the noise texture. I need it to be more subdivided or less subdivided. And then you just have this here. All right, so, and like, just as further proof, we can go Shift A, we can add a monkey in here. And we can, put generate landscape. For some reason, we need to disconnect that. Do we always need to add a new one and then generate landscape? Look, and now Suzanne has a landscape. Ooh, change the scale if you want. 4. There is a way to, like, if you wanted this to be a random value each time, there's like sort of a way to do it. I think you have to add another like input like this, and it would be like scene time or something like this, like seconds, and I don't know. Or like, yeah, or no, because that would do something else. There's a way to do. It's not as simple as like, because there is a random value here like that, but it generates a single random value. So like anything you put it on, it's going to be the same. So you would need something that would like change this seed for each thing. There's a way to do it, but I think it's complicated. But anyway, let's change this back to be like, whoops, not negative, make it like 3. And change the scale to be a little less crazy. Okay, one other cool thing is that you can, so like if you don't want to be kind of working in the geometry workspace, so let's say for example you do want to be able to adjust the scale on the fly. You can see that in the group input there is this like kind of ghost socket here. You can plug this into any value here, and it's going to make it available kind of outside. So if I plug it into scale here like this, you can see that there is, now we have this scale thing here, which appears over here on the modifiers tab. So then if you're like in layout mode and you're like, okay, yep, working on this thing, selecting this, let me go to the modifiers. Oh yeah, I just want to adjust the scale a little bit. So you can kind of make it, available to you here like this. Kind of cool. All right, let's do another example now. So we do, we've got our little landscape generator thing here. Let's hide this. And actually, I'll name this like landscape. All right, let's make a new plane here like this, and let's get into it. New node here. I'm gonna call this one like cube spinner. Usually triple clicking, cube spinner. Helps, allows me to select all the things. Okay. There's a category of geometry nodes called instances, and we can. What I want to play with is instance on points like this. Let's put it in the middle here. So what this does is it's going to put a thing on the points of this thing. I don't know if I've done a great job of explaining what an instance is, but an instance is like a copy of a thing. So let's put cubes onto all the different points here. So let's go Shift A, and I believe you can just do. I think you can just search. You know what? Mesh primitives cube. Yeah, so you can just search like this, and we can plug this mesh into that instance. And so now, because we have 4, things for what do you call it? Vertices on our plane, we have got 4 cubes. And let's actually make the size smaller. Let's make it like 0.1, 0.1, 0.1, like this. Little ones. Okay, and so now let's do our subdivide. Subdivide mesh like this. Stick it on there. And look, it's subdivided. Now I've got 9, 27. No, that's 25. And more. The other thing we can do, and actually here, let's do this too. You maybe saw that there is, we can search for a subdivision surface. You can do a subdivision surface modifier on here like this, level 1, 2. Look, and now we've got like cool balls going on in here. Yeah. So you can find anything in geometry nodes. Okay, so this is kind of cool. So we're making some generative stuff here. Okay, what other cool things can we do? So you can see on the instance on points here node, you can rotate them all together. You can rotate them in the Y, or you can scale them in the X, which would be a disaster. You can scale them in the Z like that. But this is actually kind of a cool place to give it rotation. So what I'm actually going to look up right now is the different colors of the sockets. I found this on the docs. Boolean color is yellow, float. Integer is green. That was a new one. String is blue. Vector. So vector is has 3 parts. XYZ usually is purple. Pink. See, is this matching up? Texture? No. Data blocks? No, pink would be Boolean. Pick instance. Yeah. That's not super helpful. And what does the dot and the diamond mean? Somebody smarter than me will figure it out. Okay, anyway. What were we doing? Oh yeah, we're gonna kind of randomize the rotation of things. Okay, so let's go Shift A and let's just search for random value. Random value like this. And I believe if you put it into the rotation, yeah, so it gives it a random, each one has a random thing. So the closer these values are, the less random they'll be, the min and the max, but the max difference between them. And then the seed obviously will change kind of the randomness of, or the starting value of the random. It's another kind of fancy way to make noise. Okay. So it's starting to be sort of interesting. Now, let's have this. One of my favorite geometry nodes to use is the proximity node, and so it'll change things based on how close or far away a thing is to another thing. I'll show you. Oh, and actually, I should do one more thing. On our random value thing here, node. It's not a thing. This is set to float. You can set this to vector so that it more closely aligns with, the values that we are using here. So you can choose, X, Y, and Z. So if you only want the Y to rotate, for example, only the Y to be randomized, you can set the X and the Z value to be 0. And now the randomness is only happening in the x direction. So if I kind of spin the, let's make this a little bigger now. So if I wanted to spin these a little, they'd only be randomized in spinning, in one direction. Cool. Okay, so now, if we wanted to use the proximity node to kind of change this rotation based on how close a thing is, we need to add like another object in the scene here. And so I'm just going to go Shift A. I'm going to go, I think I can even do like an empty cube like this. And I'm going to rename this to be, rotation controller. Okay. And then we can go back to our plane here. And I should rename this to be like spinning boxes. And to add this add the interaction of the rotation controller into our scene here, or into our node workspace, you can actually go Shift A and create an input, and then you have scene here. And I think we would just do object info like this. And then we can choose the object here. So we can choose rotation controller like this. There we go. And maybe the shorter way to do it is you can just take rotation controller, click on spinning boxes, but click and drag it just right into your node workspace here like that. And then we've already got an object info like that. Okay, so let's see how we can have the information of this object affect the rotation. Oh, and you know what? I remembered. I realized I've made this mistake before. It can't be an empty. It needs to actually be something. Rather, let me add a new Suzanne into the scene here. Shift A, mesh monkey. Okay, this is going to be rotation control monkey. Control with one L. Rotation control monkey. Okay, great. Now we'll go back to our spinning boxes. I'm just going to select the rotation control monkey here like this. And I'm going to kind of clean these up a little bit. I'm going to collapse these ones since those ones are pretty simple. Okay, whoops. Here we go. So we've got the object info from the monkey. Let's add the it's called geometry proximity. Geometry proximity. Okay. Okay. So here we go. Here we go. Things are happening. All right. So first, let's even just disconnect the random thing. So we just want it to be based on the location of the monkey is going to affect the thing. So we're gonna do we're gonna say the distance is going to be the rotation like this. And object info. So we want to take the geometry of our rotation monkey to be the geometry proximity here. Whoops, connected that geometry to geometry. Now here's the rub. So nothing is happening because it's not measuring the distance from anything yet. We're just saying, hey, the proximity of this to itself, is how you're going to affect the rotation. So rather, we need one more thing, and we need the position of the geometry for the current object. So we just need one more input, and that's going to be it is which one? Hold on. It's in geometry, and we need to read the position. So that would be like the position of the geometry that it's looking at. So bear with me. Here we go. So we're going to plug this into sample position like this. And now I believe, let's see if this does a thing. No, hold on. Still not there. Okay, I have a suspicion. I think I know. I believe it's looking at, I believe I need the rotation control monkey to be in a separate collection. I kind of remember this being a thing. So I'm going to put rotation control monkey in here. Is this going to change anything? No. Oh man, have I forgotten how this works? Am I making this more complicated than it needs to be? How about this? Let me just try to make this something different. Let's do, no, because I think we need, if I do this geometry to here, let's do a vector math. Vector math, that might be in here. Vector math like this. And let's do, put in this position and this position like this, right? And this is going to be distance like this. Value. Okay. Like that. It's not, it does nothing. Oh, I realized my fatal error. Okay, I think I was overdoing all this. There's this toggle here. Look at the object info. It's looking at the original information of the object. We need to change this to relative. Okay, so let me try to do this. Sample position, distance. Let's just plug that into the rotation like this. And because now if I move it, it's just silly little thing. Okay, we want the object info of the rotation control monkey relative, so as it changes. So you can see now it's doing a cool thing. So it's rotating as this gets closer and cooler and things like that. Okay, so now, we can do a little bit more fun things like this. So let's say now we do, and so let's just kind of organize these a little bit. We can put this into here, and we can do another vector math like this. Vector math, put this in between, and we want to, we're going to multiply these. So do the distance here like this, and multiply. So it's multiplying by 0. Let me get in a little closer. We're taking the distance of this to that, and we're going to, I did a random value. So rather than do a random, we can just say like 1 like this. So it's multiplying the other ones by 0, and the x is going to rotate like this. So kind of cool. So like you can kind of do the math here a little bit. So like this one in the middle, the proximity is like the same. So it's not going to rotate at all. But as we move, if you look at just that center box there, as it goes this way, it rotates. As it goes this way, it rotates the same direction. So cool things happening. Okay. I want to show you one other cool thing that I've seen people do in Blender or with geometry nodes is like it is more of the like procedural way of thinking about geometry nodes. And so what I want to do is I'm going to create like a super duper basic like shelf, like bookshelf, but that with like a simple input, you can like change the number of shelves on a bookshelf. So let's get this set up. Okay, so let's start with the cube, just as like a starting thing, but it really doesn't make a difference because we're not even going to use the geometry of the cube. So we're going to disconnect this. So we've got inputs and our geometry output. Shift A. We're going to put a cube back in here, but just so we can have total control over it. Mesh primitive cube. Boom. Great. We're going to do instance on points like we did before. Instance on points like this. Now, we're going to use the a mesh that we create to kind of control the size and shape of our like bookshelf that we're going to make. So the cube is going to be the instance like this. And then the points of the mesh that we're going to use is going to be generated. So there's a node that we can use called mesh line. So it just makes, a line of meshes. And actually, so let's just connect the geometry out here like this. And so you can see when I connect mesh line to points here like this, you can see it made a line of 10 points like this. So you can see there's 10 here of difference of 1, but we can actually just set this to 0, and we only want 1 because we're going to start with 1. Okay, great. Okay, so you can see here we've got our one cube on here because there's one point on our mesh line. This is the start location. This is what we need to manipulate. So we're gonna do. So you can see start location is a vector. It's purple, but there's a handy node that's called combine XYZ, and so it converts 3 values into a vector like this. So we can plug this into here. And then, you can say, do that, whatever. And then we're just going to change the X value to kind of be, the X is going to be like the width of our bookshelf. Just follow along with me and skip ahead really if you really want to. So we're going to have an input of this be, so you can see in our geometry notes here, this X width is going to be the one that we manipulate here. And we can rename this. I believe if you hit N like this, while you're in the node workspace, you can rename these sockets. So I think we can just call this like width for now, right? How do I rename this? I think, you have to click on the node. Click here, right? Can I do this? Width. Oh, no. Property. How do I I thought you could rename this. Group, tool. Could I rename it here? Whatever. I'm not going to worry about it. So this is going to be like one side of our bookcase. And so now we need to make the other side. So I'm going to select these 3. I'm going to Shift D to duplicate that. And let's see. We also need, so first we're going to need to combine both sides. So we're going to need there's a combine, is it geometry? Or is it join geometry? I saw it. I should just search for join geometry. Here it is. Put this one in here, connect this one here like this. It'll join them together. But now, so we need to have, another math. So you'll see what I'm doing in a second. This initial setup is kind of part of the fun of learning. Fun. Okay, so if I can connect this vector here to this start location, but we need to like have this one be the inverse. So like if this one's moving to the left, we want the other one to move to the right. So we just need to have another math, vector math like this. And we want the X value, which would be the first one, to be -1. Right? So that they move apart from each other? No. Oh no, oops, and I have it set to add, so actually rather we need to multiply. So like you can see these are the 2 sides, and so if I wanted it to be a wider shelf, I'd have a wider X value like this, a narrower shelf like this. Okay. Now we're cooking a little bit. Oh, here we go. It turns out I just needed to double click on this. This is going to be cabinet width. Okay, and so now, like, hopefully this is starting to like unlock all of these different like potentials for this. So so we need to like make the sides of our bookcase skinnier. So let's just do another combine XYZ like this, Shift D, and we can plug this into both the scale for this one and this one, and they went away because it's 0. But we can say, X scale is going to be like 0.1 like this, Y is going to be, 1, and Z is going to be 1 like this. Like that's one section of bookshelf there, of like the walls, for example. And, you could have this be another input. So you can actually drag it back this way like this too. You can go the other way. And this one can be, like board width, maybe. So you can change the board width if you really wanted to. I'm going to leave it 0.1. We can make the cabinet width a little bit narrower like this. Okay, let's keep going. Okay, so let's make another one of these. I'm gonna Shift D to duplicate this. This one can be like our like bottom board or whatever. And like we can label things too. Like maybe all of this needs to be. We call this. You can make a group. Make a group. No, I don't want to do that. Rather than make a group, you can join a new frame like this, and you can label this to be. How do we label this? Rename here. Node label. This could, this is like left board or something like that. I'm not gonna do that. Okay, so this is gonna be like our bottom one here. Mesh line. Let's see. Multiply. Nope. We want combine X, Y, Z. I believe. Shift D like this. And this is going to be the scale of this one, right? Vector scale. I know it's tiny. But rather than that, we'll make it 1, and then the Z scale will be 0.1. But here's the other thing. How do we get this to like line up with the width of the thing? So this is where you have to get like kind of clever with your math a little bit. So if I join these out, why don't I put these into a new frame here like this? So this will be like, let me rename this to be bottom board or something. Bottom board. And really, maybe it should be like the top board or something. You can get clever with this if you really wanted to. Okay, and start location, let's actually have it be like right at the top. So that would be, 0.5 like this. But we want the scale, the X scale, to be representative of, our cabinet width. So I believe, let's see. So we want to have an input into here like this. So we want to take this cabinet width vector and stick it into here. No, we don't want the vector. Actually, I think we just want the cabinet width, the cabinet width value to go into the X like this. And did I grab the right one? Board width. Nope, I grabbed board width. I wanted cabinet width to go down into the X value here. But it's only half, so we need to just like add another math node in here. Shift A, math, just like regular math. Utilities math. Okay, add, and rather we want multiply by Q. And that'll put it right on there. So you need to like account for the like thickness of the board, 2.1. And maybe the offset needs to also have that 0.1. So like you can have it be, so like I'm gonna like be really, so rather than 2.1, you make it 2. How do I make this box bigger? There we go. Okay. You do another math, shifty like this, but instead of multiply, you do add, and the value of that is going to be plus the board width. So all of this can be like a generative and procedural. And then we're also going to add on top of this, where's our offset? Here on the mesh line, we have this set to 0.5. Rather, I'm going to do a new thing here, Shift D. I'm going to put this here. This value is going to go into, okay, but we need to combine X, Y, Z. Hold on. Let's Shift D this here too. Do you see what I'm doing? I'm going to plug this vector into the start location here. It's going to be 0, 0, 0. But then this X value is going to be this. Nope, it's not going to be the X. It's going to be the Z. You see it's floating way too high, but we want to take Okay, this 0, 0. So we want to add half of the height. So the height would be another thing that you'd have to determine, but we know the height is going to be like 1. So it would be half of the board height plus, or half of the height of the thing plus half of the board width. So it's going to be board width like that, but then that divided by 2. So you need another one. Shift D. Put that on here. This is going to be divide. So it's that value divided by 2. And that's going to rest exactly on there. Whew. Wow. Okay. But now that you have this set up, let's see. This is that. So now you could say the instance of each of these can change. Okay. But we got to take all of our mesh lines. So the mesh line, if we do, let me just do count 2 like this. Z is like value of 1 like that. So there should be another one floating above. So this one would be mesh line, value 2, Z 1, like that. Same like this. Value mesh count 2, value 1 like this. And so like we can have a new input here that plugs into count like this, and you can use that count. I know it's so small. Put that count here, put that count here, put this count up here, like this. I have 2 counts. Why is this one 12? Is that one plugged into anything? I don't need this count. I don't know what that is. This count, remove that. Okay, this one is going to be like number of shelves. And then you can just go ding ding. Like you can just go ding 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 ding. Like 6, 7, 8. Like it's 1,000,000 shelves. Ding 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 ding. And you're thinking like, well, Nolan, I could just do array. I could just make one and do an array. Yeah, you could, but like, could an array do like this? Yeah, but like, okay, I'll show you one more thing. This would be like how you could put a material on here. So there's a node. Let's go to render preview. Let's shift A, add a mesh like this. GZ, move this up a little bit. And shift A, we need a light. Light brighter. Okay. Am I in cycles? Nope. Okay. So there's a node that's just like set material like this. And so let's make a new material. New material, we can call this, gold. Gold. I must like the gold material. And roughness down and make it yellow like this. Okay, and then here on the set material thing, you can say gold. And so it can be on a per part of this basis, or you can have it set at the end too. Shift D, set it here, and set it for the whole thing, and you can close that, cut that off. So again, this is like a I forgot. This is a super duper basic example, but I did that in just a few minutes. But if you think about like, I've seen people do like really cool furniture or like buildings, like procedural buildings, like if the width of the thing, or like if you add an instance, it just generates a whole new building. It takes a lot of setup ahead of time. Like even like look at all the nodes just now, with just that's all we did. And it's like, Nolan, I could have just extruded a thing and been done in a few minutes. But I'm just trying to illustrate like the power of nodes and procedural modeling. Because once you have the setup, then you can go fun. But and it's like you can just change the board width like this. I think this is one of the other things. Our board width math wasn't very good because I didn't plug the board width into this. Okay, let me plug the board width into that real quick. So the bottom board, we want the size. Okay, what is board width doing here? Board width is going into the value. Okay, hold on. I want to figure this out. Bottom board width. So that would be the scale, the Z scale like this, right? Okay. So we had it plugged into the X scale here. So we just need another, we just need the Z, the board width, to go into this Z, I believe is all we need, right? So if I change the board width here, yes. See, look, our math is already paying off. Look at the math. That changes. Now this changes. Now if we go up. Okay. Now I really need to make sure. Okay, this is going to be the last math challenge for me. This is just turning into like a little Nolan puzzle. Sorry. Okay, so we want the height. We want the, we need to change the mesh line offset. I have it set to 1.1, and rather we need it to be like 1 plus the value of the thickness. So here we go. The board width. So this is the offset XYZ. We need to combine. We need another combine XYZ like this. Shift D like this. Board width is going to go into the Z. Okay, hold on. So I'm not there yet. The board width, and then we need a math. We need regular math like this. Math. We're gonna do 1 plus that. Whoops. Okay, hold on. I'm getting my wires crossed. It's not the one I wanted. Undo that. Undo this. This vector was supposed to go into the start location like that. I want this to go here. It's going to be add 1 plus that value. And we need this. I need this for all of these. So I need this one and this one. I need to shift D to duplicate that for, I know my things are getting out of whack. This one is going to go into the offset for here. And board width goes into this one. +1, okay. And then same thing with the bottom board. I need these two, shift D, bring those over there. That vector goes into the offset here, and we need the board width to go into this top value here. Okay, so now check this out. Check me out. The cabinet width, the board width. As long as it doesn't like go negative, then it's a problem. And then the number of shelves, ding, 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 ding. Oh, it's magic. When the math works, it just feels good. It feels right. Feeling good. Did I do good? That's all the geometry nodes. And this is just a cube. And really, like, the cube doesn't even matter. We could have done it on a plane. There's my ground plane. Okay. I know. I'm sorry. I have a feeling there's a couple of you that might get excited about geometry nodes and things like that. And this is one of those things where you might look like there's so many like people on YouTube that make a video that's like, here's how you can make a crazy ball that peels back like an orange or peels like an onion and there's things inside and whatever. And like that's a cool tutorial to follow, and then you'll have a cool orange that peels back. But you're still not left with like quite an understanding of how to do something on your own. But you at least know you have some exposure to some of the different nodes. So like the ones that I exposed you to with today are like, instance on points. Whoops, and I'm not sharing my screen anymore. But instance on points, you're going to use that one a lot. you'll be generating cubes a lot. You'll be maybe mesh line. Understanding that you need to do math. That like, oh, if I want something to do the opposite of another thing, I need to multiply the value by -1. Multiply by -1 equals opposite. If I am wanting values to like be added together or to account for like the difference of something that's symmetrical, you divide by 2 or like multiply by 1/2. So it's not for the faint of heart. You need to have a basic understanding of like math functions and problem solving and things like that. But okay. Pause for a second. Okay, so that's it for this week. You have your game asset assignment due next week, and then really start thinking about what you're going to do for your final project as my voice goes down here. We'll Zoom next week as well. Week after that is Thanksgiving, so then we'll have like a little bit of an extended time away, it's time apart. But yeah, so that's just a tiny introduction into geometry nodes. Email if you have questions about your game assignment or anything else, and look forward to seeing you next week. Bye.